Hello everyone. In the last video I created an autonomous agent which decides based on the response if tool needs to be called or not. The decision comes from the LLM response. So based on the prompt, LLM gives a response with that suggestion that you should book an appointment or not. And then this agent just follows that based on the response. It decides and calls the tool. But a complex agentic solution cannot just run on one single agent. We need to have multiple agents working together, coordinating with each other, sending one agent response to another, and then continuing the chain and together giving out a solution. So in this video, I will talk about multi-agent system. So how we make this auto agent a multi-agent system. If you see this agent class, auto agent class, it has a prompt, right, inbuilt into this class. So if we instantiate this class, it will always follow this instruction. In a multi-agent system, the instructions are outside of this agent, and same class is instantiated with different instruction. We already have LLM and tool being passed through the constructor. We also need to pass the prompt. So everything is coming from the outside. So we can instantiate same auto agent class with different instructions, different LLM and different tool. So when we instantiate two auto agent with different instruction, it will become two agent, and then we need to coordinate between them. So here I will create auto agent 1 as this auto agent and LLM and the tool, but the instruction is inside this, right? If I create auto agent 2, I can pass different LLM, different tool, but the instruction will be same. It will always do this same thing. But in the second agent, I want this agent to do different thing, right? So I will extract this prompt outside. Instead of passing a symptom, I'll pass instruction, prompt. And prompt we will pass from constructor. and just call execute. So this one agent will provide advice based on the symptom, which is cough. Now I want to create another agent which will have different instruction. What could that instruction be? So if you see, this agent is giving advice based on the symptom, but can a doctor advise based on just symptom, that I say cough or I have cough? Can a doctor advise any good suggestion, good treatment? No. Doctor needs more information. So until this agent, which is acting as doctor, which is providing advice, until it has a detailed instruction, detailed information about the symptoms or what is happening with the patient, it cannot suggest a good solution. So before asking this agent to provide advice, we want to collect proper information from the patient, and that we will do through another agent, that is inquiry agent. What this inquiry agent will do is, it will ask questions. If patients say I have cough, it will ask question: from when, since when, what kind of cough, right? So based on its input, patient's input, it will generate questions and ask it to the user. And until it satisfies that it has proper information, it will keep asking the question. When it is satisfied, then it will pass the whole information to this another agent. So in this case, we will have two agents and coordinating with each other. So this agent will be advisor agent, and before an advisor agent, we want, okay, ask question to understand the symptom or the problem in detail. So this same agent class will be only one. We will not create different classes for different agent. Class will be same, but it will have different inputs, different LLM, different tool, different instruction, right? So this advisor agent will have tool to book an appointment, but this inquiry agent will have a tool to send questions. Suppose there is a chat box. User sends cough. That chat message will be sent to the backend, and it will come to this inquiry agent, and it will send that to LLM. It will generate questions, and now that question needs to be displayed on the chat window, and that will happen through a tool. So that question will be given to a tool. That tool will send it to the chat window. So we need a tool which can be used by this agent to send it to the chat window. So here instead of Practo tool, we need a chat tool or messenger tool, which will internally call messenger API to send message. Okay, so this messenger tool will have a name. It will again have some API, URL, key, and it will make an HTTP call which will send the message to the chat window. So here in this case, this auto agent will have this tool as messenger tool. This prompt will be sent to the LLM. LLM will generate questions, like it has instruction ask questions to understand the problem. So it will generate question, and based on the response it will use the tool. So here in this case it will always say that to use tool. So this messenger tool will be used to send the response. So that response, I mean, that will be the questions which will be answered. That answer again will come to this inquiry agent, which can be passed here. Suppose chat window sends the input, chat input or chat messages. This is coming from the chat window, so it will be passed to this agent. This message will be in the prompt. It will go to the LLM. LLM will see that ask question to understand the problem, and it will see all the messages. So it will see, okay, I have asked all questions or I have not asked questions. Based on that it will respond, and then it will use the tool. If it is satisfied, then it will say no action needed. If it is not satisfied, then it will generate question and it will be sent to the chat window using the messenger tool. When it is satisfied, it will say no action needed and this will end. And then the control will go to this auto agent, which will also get this chat messages. Instead of this cuff, it will get access to the chat messages. So provide advice for the symptom or for the problem here. So this again will go to the LLM, and based on this all problems it will generate advice. Based on the advice it will book an appointment or just say no action needed or you are fine and all. Okay, so this way we can convert one single agent class into multiple agent instances with different instructions and different tools, different LLMs. Some LLM is good for some tasks, some LLM, other LLM is good for other tasks. So based on the problem, we pass the different LLM also. Tools is definitely needed different and the instructions. So this autonomous agent becomes a template to create multiple agents, and these agents interact, coordinate with each other to complete the problem at hand. So this is very basic demo sample code of this problem. To actually run it, we need to do some tweaking, but the basic blueprint is same. We will have an agent class, autonomous agent, which will have this execute method. It will take prompt and LLM. It will pass that prompt to the LLM, generate response. It will have a logic which can be complex logic. Based on the problem domain, we need to write this logic which will decide whether the LLM response is asking us to use the tool or not. So based on that, it will use tool, take the action, or it will say no action needed. So we create this one agent class, then we instantiate it based on the requirement with different LLM, different tool, and different instruction or prompt. So when we pass different instruction, different LLM and different tool, it becomes a different agent. So here it will become the same auto agent class will become inquiry agent. The same auto agent class will become advisor agent, and these two will coordinate with each other, right? Same way we can have more agents instances, inquiry agent, advisor agent, and some other diet agent or reporting agent and all those things, right? So here when we have just two simple agents, their interaction is based on the messages. They have both access to the messages. This auto agent generate question, user answers, and everything is in the chat message, and that is sent to the advisor agent, and it generates advice based on that chat message. So this way this simple interaction is taken care of. But in more practical scenarios, we will have different situations. There might not be any shared variables. There can be 10 plus agents. So in that case, the interactions, the coordination are not like sequential. Then there are lot of different logics, like if this happens, then call agent A. If this happens, call agent B. So there will be the whole decision tree to decide which agents to call. In that case, we need a coordinator or manager, right? So in a multi-agent system, we always have multiple agents and a manager, a coordinator. So every agentic framework has this concept, and they call their manager different things. Like Crew AI call their manager as Crew. So Crew is the manager who coordinates between multiple agents. So in advanced cases, we need to create a crew class or a manager class. Okay, and this manager will have the coordination logic which we have to create. If we are creating this manual manager class, then that logic we have to implement here. This decide to use tool we have to implement. Okay, and based on the complex scenarios, these logic become very complex, and that is why we use different agentic framework where such logics are inbuilt. They have already implemented these logics. So when we do this everything manual, we have to write this decide to use tool and this coordination logic, how these two different agents or 10 plus agents will coordinate. Until we have proper inquiry, we cannot call advisor agent, right? So here the simple logic is chat messages, but in different scenarios it can be some complex logic. So that logic has to be implemented here. And if we are using any framework, then we don't have to worry about that. That is implemented inside that framework. So we have two options. Either we implement these logic, which is also a good thing. We can do advanced uh, framework level thing, right? Implement this, or mainly for these purposes, switch to some advanced agentic framework which handles all these things. So we have this auto agent class, which is a simple class, but in the framework the same agent will be even smarter. Their manager will be super smart, and creating these agents will have different syntax, right? But at the core it will be similar to this. They will have one agent class which will execute. It will take the prompt, send it to the LLM, get the response. Based on response it will use tools. Right here we have implemented one tool in the framework. There will be multiple tool handling. So this way this agent class will be created, and then based on the instructions we can create multiple instances, handle the coordination between them, right? So this core part will be same in every framework, but the implementation, the complex logic will be different. So when we use those frameworks, we don't have to create this agent, this logic, and this manager class. So I have explained you the core concept, the basic structure of any agentic framework, basic requirement. But going forward, we will use any agentic framework, and in our case that will be Crew AI framework. So stay tuned. In the next video we will switch this problem to use Crew AI. Thank you.